Assalamu alaikum. My name is Anam Zaved and my registration number is 16T82. Welcome to the lecture of digital signal processing. In today's lecture we will discuss window method. Window method is applied when there are sharp transition due to the high frequency. This phenomenon is known as Gibbs oscillation. As it is written here, the first point is the window method is developed to remedy the undesirable Gibbs oscillations in the pass band and stop band of the designed FIR filters. Second point is Gibbs effect is due to the high frequencies and sharp transition. The common windows that are used in FIR filter design are as follows. Number first is rectangular window. It is given as W rectangular n equals to 1 and its range is from -m to m. M here represents the number of taps. Number second is rectangular window. Its formula is given as W rectangular equals to 1 minus mod of n divided by m, and its range is also from -m to m. Number third is Henning window. Henning window formula is given as 0.5 plus 0.5 cos of n pi by m, and m here ranges from -m to positive m. Number fourth window is Hamming window. Hamming window equals to 0.54 plus 0.46 cos of m pi by m. M again vary from -m to positive m. Number fifth one is Blackman window. Blackman window formula is given as 0.42 plus 0.5 cos of n pi by m plus 0.8 cos 2 pi to n pi divided by m. M again varies from -m to m. We will use this formula of low pass filter in the next example. Example is given as we have to design a 3 taps FIR low pass filter. Its cutoff frequency is given as 800 Hz and a sampling rate that is f of s is 8000 Hz. Firstly, we have to calculate the cutoff frequency, that is omega c. Omega c equals to 2 pi fc into ts. Ts comes from sampling frequency, as it is the reciprocal of sampling frequency. 2 pi is the constant, fc cutoff frequency is 800, and ts comes from the reciprocal of sampling frequency, that is 1 over 8000, and after calculating this we will get the cutoff frequency as 0.2 pi radian. The next step is to calculate the number of taps, that is m, as we have to design a 3 taps filter, so here n equals to 3. The formula is 2m plus 1 equals to 3, and from here m comes out to be 1. The next step that we have to do is to calculate the impulse response. How we can calculate the impulse response? By varying the number of n. For n equals to 0 and for n not equals to 0, we will use this formula for the low pass filter. When n is equal to 0, we will use cutoff frequency divided by pi to calculate the impulse response, and when n is not equals to 0, that is other than 0, we will use this formula sin omega c n divided by n pi. Here when n equals to 0, the impulse response come out to be 0.2, and when n is not equal to 0, means for other values of 0, here it is given as n is taken as 1, its value come out to be 0.187. Due to the symmetry, the value that is on 1 will also appear on the value at -1. Now the third step is to apply the window. We will use the window formula for, we will apply Hamming window. The formula for Hamming window is this one. Number 4, 0.54 plus 0.46 cos n pi by m. We will use this formula to find the window. We have just put the values and calculated the window. At n equals to 0, it's come out to be 1, and n equals to 1, the window value come out to be 0.08. Due to the symmetry, whatever is the value of window at 1, it will also appear on the -1, and its value is going to be the same, that is 0.08. The last thing is that we have to multiply the window value with the impulse response at their respective value of n. Means if at n equals to 0, we have to multiply the impulse response of n equals to 0 with the window value of n equals to 0. Here HW of 0 equals to H of 0 multiplied with the window value of n equals to 0. H of 0 is the impulse response at n equals to 0, that is 0.1, and 1 is the window value at n equals to 0. When these two are multiplied, the result is 0.2. Similarly, we have calculated the window value at n equals to 1 and just multiplied the impulse response with the window value at n equals to 1, and this comes out to be 0.01497. Due to the symmetry, this is going to be the same at n equals to minus 1. As we calculate the value by using the formula 2m plus 1 equals to 3 and it's come out to be 1, we have to delay our window by 1 to calculate the coefficients. The coefficients come out to be b0 and b2 equals to 0.01496 and b1 equals to 0.2. Due to the symmetry, b0 and b2 have the same values. Now we have to calculate the transfer function simply by using the equation of b0 x1 z minus 1 plus b2 z n minus 1. We have just put the values of the coefficient over here, and we can write it as h of z equals to 0.01497 plus 0.2 z of minus 1 plus 0.01497 z of minus 2. By using the Euler's formula, we have just calculated the magnitude and have plot both magnitude response and the phase response over here. This is a simple example of how we can apply window to avoid the sharp transition due to the high frequencies. Thank you for watching.